name is Ramesh Kartik. I have got 11 years of experience in industry, which includes software design and development, project management, and a blogger and a tech speaker. Okay, it's good to see that most of the people participating in this TypeScript, even that too on the weekend. It's great that. Okay, so what I'm good at and the reason why I'm here is to give you all a brief session on a TypeScript today. At the same time, maybe the one more reason could be like connecting different people, right people from various locations and finding great areas in a room together, right, and discussing it. Okay, please note it down my Twitter ID at Ramesh Kartik RS and my personal blog as well, techcoppings@wordpress.com. In case if you have any questions, if you have any clarifications, even after the session, I may not be able to solve all the queries. So you can directly ping me back after some time. I will definitely help you sometime later. Okay. Yeah, about C Corner, I would like to say a few words about C Corner. I hope everyone know that C Corner is a wonderful platform for developers and IT professionals across the globe, where you can engage for updating yourself in various recent technologies, where you can get clarified your technical questions, whatever your technology may be, career advice, and lots more, right? In simple words, it's a one-stop shop where you can enjoy various flavors of different technologies. Okay, let's get started. Okay, let's have a look at today's agenda. So today's agenda is all about the first part. We'll see introduction to TypeScript. What is TypeScript? Why we need to go for TypeScript? What other languages? What exactly the benefits are there in TypeScript? So what's special in TypeScript? Okay. So then the second thing, like how do we need to declare variables? How do we what other various options to declare the types, properties, and variables? So there's a lot of things on variables, like, and third one, like how do we need to create classes and interfaces and inheritance? How can you make object-oriented code in TypeScript? Then final one is loader, like how can you able to how should you prepare your code loading your dependency projects when you have a lot of dependencies in your objects. So then finally summary. The first part I'm going to tell you something showing in PPT, and then second part I will show you and explain you each and everything in the source code. I have my source code with me. And at the end of the session, probably I can give you the GitHub link as well, where you can download your source code and to use it for your purpose to learn it out. Okay. Okay. Yes. So what is the need of one more language? I know JS, I know JavaScript, then why should I learn one more language? Why should I go and code in TypeScript and compile it to JavaScript? So what's special in TypeScript, right? So everyone will be keep asking like this only. So people who come to JavaScript from programming languages like C Sharp, Java, they're basically server-side programmers using C Sharp, Java, right? So, so they really want to enjoy the browser power using JavaScript, right? So, but if you see the mentality or thought process of a server-side programmers like C Sharp, Java are object-oriented, right? So they would like to see everything in object-oriented interfaces, inheritance, and polymorphism. So basically, they are from a sophisticated traditional background of object-oriented programming. Right? So that's the thing. And the time when those people can come to JavaScript, there are no classes with me. If you want to create a class, you have you have to use functions. If you want to use inheritance, you have to use prototype in JavaScript. So people come to JavaScript, suddenly they feel into a different world. So most of the syntax are completely different how they used to be in C Sharp or Java. Like, so this is you just look at this code. This is a simple employee class, right? Okay, a simple employee class and properties and functions. So many person who comes from C Sharp or Java background, it is so difficult to manage this class. And this is a function, right? I think somebody, can you mute yourself please? Unless otherwise if you have any questions. Yeah, thanks for that. So from any person who comes from C Sharp or Java background, it is so difficult to digest. This is a class and this is a function. You can see this is a class and this is a function, right? So they would like to see class, extends, interface, and inheritance, right? But you can't able to see everything here in JavaScript. That's where the TypeScript comes in. So TypeScript says that I understand that is very difficult to grasp the concepts of JavaScript. Okay, so TypeScript is a supercoding language. You can write class in interface the way you write in C# or Java. Then I will compile into a plain JavaScript. Okay. So at the end of the day, TypeScript is a transpiler. So transpiler means converting from one language to other language. Here actually in this case we are converting from TypeScript to JavaScript. So whatever the code that you write in TypeScript, at the end of the day it is going to be converted into the JavaScript. So again I repeat that TypeScript is actually a supercoding language. Okay. Yeah. So JS actually fills the code in this way. If you don't follow any parent over there, it tends to feel a little bit messy. As a result, messiness leads to lack of maintainability, lack of reuse. So you don't feel any structure in your code actually in JavaScript. So that is the major drawback over here. So, but in case of TypeScript, we want something to be filled like this. We want very maintainable code and easy to work with. That's the one of the things the TypeScript actually really do. So you can find that easily difference between the TypeScript in case of JavaScript, since they don't follow any parent-child relationship or anything, so a lot of messiness will be there in case of JavaScript. But in case of TypeScript, you can write your own code in object-oriented manner. So whatever the code that you are writing in TypeScript, at the end of the day, it's clean and maintainable code. So that's one of the very important highlighting points in TypeScript actually. Yeah. So here, no, the TypeScript is so if you go and browse and if you go and find out the definition of TypeScript in any websites or any website, you can find this definition. So it's TypeScript is a type superset of JavaScript. So that compares to a plain JavaScript. What does this mean actually? So first of all, what the superset means? No? So you just think about what exactly the general meaning of superset. Superset means a set which includes other set. So which means in our case, which means a set of JavaScript features plus some additional features. That is the TypeScript. So TypeScript is it's a JavaScript features plus additional features. So in other words, we can say that TypeScript is an extension of JavaScript. So any syntactically valid JavaScript you write today is perfectly compatible with TS, with TypeScript. So TS means the TypeScript. Even you can also intermix your JavaScript and the TypeScript code without any issues. So that's it. Again, I repeat, like TypeScript is actually extension of JavaScript where you can enjoy your JavaScript features and also that plus TypeScript features. That's a notable point over here. Of course, TypeScript is a free and open source programming language. Yeah, let's have a look on how far the TypeScript has come from. In 2010, Anders and team began the development. Anders is none other than the one who designed the C# Visual Studio, C#. In 2012, the first public version 0.8 released. And 2013, right? TS.9 released the generic support. And 2014 they have released the Visual Studio support. In 2017, like here, no, 2.1 and 2.2 also get released. Yeah, there are a lot of versions, a lot of things happening in case of TypeScript. Actually, there's a long way for the TypeScript to evolve in industry. So even you know that even Angular 2 also come up with TypeScript nowadays. Yeah. So TypeScript is actually portable across any browsers or operating systems. It can run on any environment that JavaScript runs on. So TypeScript doesn't need a dedicated VM or a special runtime to execute. Okay, so this is one of the main point that everyone. Many of them are assuming like they will be having a separate runtime or something to get it executed. No, nothing like that. It's a supercoding language. So whatever the code you write, the end of the day is getting converted into JS. So it can run on any environment where JS runs. So there doesn't need any specific settings or specific environment for you to run TypeScript. Yeah, just have a look on how it is compiled. Huh? So if you look at this picture, like you can find that the TypeScript is actually kind of language you can go and write in that language. When you go and compile, no, it compiles into a plain JavaScript code. I already mentioned like it's a superset of Java that once whatever you write in TS, it gets converted into JS, right? So it here actually the transcript compiler, so the TypeScript compiler converts the instructions that are there, TypeScript instructions written in TypeScript to its JavaScript equivalent. Okay, so yes, every TypeScript code has to be compiled into JavaScript before it can run on any JavaScript engine, either browser and any browser. So TypeScript code can also get compiled from Node.js. That is something different. So in this picture, you can see that so whatever the TypeScript instructions that are there, it has to be compiled. It has to be transpiled by the TypeScript, and it converts into the JavaScript. So and at the end of the day, I already mentioned like what the code what you write in TS will get converted into the JavaScript. So that is a simple theory behind this. Yeah. So of course, TypeScript is actually a strongly typed and object-oriented language. It supports classes, inheritance, interface, properties, as like how you seen in C Java. As mentioned here, right, we can create objects and properties associated with each. With that, the whole project is an object-oriented, which makes it easy for you to maintain larger projects source code. In case of JavaScript, you do not have any option to maintain your code in object-oriented manner. So that I already mentioned, like it may lead to many messy in your source code. Then it's hard to maintain your large scale projects. So here actually that problem gets solved with the help of TypeScript. Yes. Yes, of course. There are a lot of alternatives to TypeScript to overcome the flaws and limitations of base JavaScript. No, many alternative programming languages has come up, including CoffeeScript and TypeScript. So that also compares to plain JavaScript. So in the end, even the CoffeeScript also, the CoffeeScript is the most widely used language as an alternative to JavaScript. So the CoffeeScript takes inspiration from Ruby and Python. You can smell the taste of Ruby and PHP in CoffeeScript code. That also, at the end of the day, it compares to neat and clean JavaScript code. So other than that, existing JavaScript code also be included as part of the CoffeeScript code. So you have other alternatives as well. Not only the TypeScript is the only option, the CoffeeScript is also there. But in case if you want to go for classes, inheritance, and everything, right? TypeScript is the only choice. Okay, I just want to figure out why TypeScript is a much needed language for you to know. Yes, the finally like okay. So to get it installed, install TypeScript in your machine, you can achieve it in two ways. Either you can do it by Node Package Manager, that is via the Node Package Manager command prompt, or by using the direct link as it's mentioned, TypeScript language lang.org/download. You can download it. So NPM, now I think you guys should have know that it's the largest ecosystem of open source libraries in the world. It helps to get any JavaScript framework package. So to get it installed, right, you have to use Node.js command prompt and simply type npm install TypeScript. It will install the TypeScript to your thing. But I would recommend, like, whenever you install TypeScript, please close your Visual Studio. Sometimes I could see few issues on that. So once you close that Visual Studio, then you can install TypeScript either by using this link or Node.js command prompt. Then you can, after that you can reopen your Visual Studio Code, either it is 2015 or 2017, whichever it is. Okay, so this is what your only thing you have to do to use TypeScript in your code. Okay. Yes. Yeah. So the next one, that's what. So far we have seen like what is the TypeScript, why, what's special over there, why we have to come to the TypeScript and everything, like. So how it is actually compiled, what are the special features over there, right? Now we are just we are going to see what are the types which are available in the TypeScript. No? So if you think, if you here if you see that, no, any data type. So any data type is the super type of all types in TypeScript. Okay, we may need to describe the type of the variable that we do not know when we are writing the application. I I agree that. So these values may come from dynamic content, right? Is it from third-party library or a other third, or a DB or anything? So it's a dynamic content. In these cases, we do not know what type of value that is actually coming from the third-party library, right? For any API, whichever the case is. So in these cases, we want to upload the type checking and let the values pass through the compile time checks. Okay. To do so, we label these things with the any type. So the any type is a powerful way to work with existing JavaScript code and also allowing you to gradually opt in or opt out your type checking during compilation. Okay. Any type is really handy if you know some part of type. As I mentioned, like if you do not know, if you are not sure what kind of data is that a third-party library or API that will be giving, then you can simply declare it in any. So any will actually can welcome you, can welcome you to assign any type of any data type. Can help you, will help you to store any type of data over there. Even if you want to assign integer or a string, anything, you can do that. Okay. So that's what. So it will be, no, if you do not have any idea what type of data that will be coming, you please go for any data type. Okay. And also that then any has two subtypes. One is the built-in types and user-defined types. So built-in types, so on user-defined types, it's hardly all the same. You don't feel any difference with the other languages. So if you want to, the number is actually it can be used to represent both integers and fractions, strings, then sequence of Unicode characters. Then Boolean, of course, it represents logical values, true, false. Then void used from the function data types. Then finally you can see that null, right? Null is an assignment value. It can be assigned to a variable as a representation of no value. Okay. And then undefined. So undefined, many of them get confused with that. What is the difference between the null and the undefined? Probably this would be the right time to tell about that. So undefined means a variable that has been declared but has not been assigned a value. Okay. So that's quite difference between there. Then user different types, of course, it's all remains same, that arrays, enums, class, and I'm not going to explain each and everything since you guys have already come from that way in other languages, right? Yeah. So if you see the screen, you can find out how you need to declare your variable. Okay. So you can find that, no. So C# or Java user has to put your identifier in the annotation in the beginning and the identifier in the last, right? But this case you have to first declare your identifier in the beginning. Okay, what is the identifier? In our case, its name is an identifier, right? Then what is an annotation? Here it is string. So you have to use colon in between your identifier and the type annotation. Then you can assign your value equal to then your string data. In our case, it is just string data. So whatever the variable that you declare, you have to use your identifier in the front. So where then name and colon then string and equal to string data. So in case if you don't want to assign anything, okay, just simply click like simply mention like var name colon string. That's it. So the only difference between both of these statements is here we are actually assigning. Here we are not going to assign anything. We are just simply declared. So, but please remember that how you actually need to declare a variable. You have to use identifier first. I should come first over here. So I colon and data type. Okay, that is an annotation or data type for however the way you call it out. But you have to use identifier and colon then type. Okay. Then yeah, one more example over here. Like so, I already mentioned no the any data type. So any data type is something you do not need to you do not have any idea what type of data will be coming. So you just simply mention it like var name equal to data. So, okay, this name can be a number or a string or anything. So likewise you can declare it. So what are the one more thing is you just simply declare your any type, but you are not assigning anything. So this is the way that you have to declare your variables in TypeScript. Yeah. So yeah, next is a static typing. So in case, so due to the dynamic nature of JavaScript variables, so it can be difficult for one to identify bugs until the code is executed at runtime. Okay, so the TypeScript actually helps us to solve this by providing an optional static typing. So what is static typing? So static typing are those which type checking done at a compile time. Okay, where the dynamic type checking is done at only at the runtime. So in this example, you can see that no, you can see that variable x was initialized with number 2 in the beginning. Then x was assigned with the string data. So during the compile time itself, one can come to know the type error, whereas JavaScript will show this error only at the runtime. So this actually helps you a lot of time. Unless otherwise, it just notifies you at the beginning itself. When you go and compile by doing this mistake, maybe people used to forget it something like what is the variable that is actually initialized with 1, then what you initialize no. So there are situations like as mentioned over here, you may be initialized it with numeric though, and after that you are trying to assign a string data. Of course, this is quite wrong, right? The compiler will not accept. So static type checking feature is there in type checking. So static type checking, as already mentioned, it will show you the error, it will pop out the error. Hey, you are doing something wrong with your types what you assigned, so you have to change it out accordingly. So that will come to know on the moment once you build your project. Okay, so that is the difference actually. So so during the compile time itself, one can come to know the type error. But whereas the JavaScript, you do not have any such facility over there. So TypeScript, by using a type inference, I will explain you more about type inference later. So TypeScript, by using type inference, would notice that you are changing the type from a number to a string, right? So and you would know that this as you are typing not at runtime. So saving your valuable debugging cycle, saving your valuable time. Okay. Okay, now look at the below code. See how it is actually simplified here. So this is the first section. It shows it's a plain JavaScript code. Okay, so the primary responsibility of this particular function is like receiving number variables, type variables, and try to add it and return it. Okay, so but and also the ultimate aim of this particular function is to retrieve only the number type of variables, right? So for that, in case of JavaScript, you have to use one more line, right? So for the type checking alone, you have to place if type of that parameter not equal to number, if type of that other parameter not equal to number, you have to throw your exceptions, right? So that checking is completely avoided here in the case of type checking. So this, I mentioned no, the type checking is a TypeScript is a static typing. It's an optional static typing, right? So in the if you look at the below code, how it is been the same set has been simplified. Just simply receive your parameter number type and also receiving other parameter also in number type, then returning also in a number parameter. Okay, so it's completely a typed function actually. Where in this case, so think about the other case. Okay, in case of JavaScript, when you once you do that, unfortunately you are actually supplying string data type in the place of number. Okay, so in that case you will be not get notified. You will get an exception only at the runtime, right? Only at the runtime you would be able to know the mistake that you have done. But in the case of TypeScript, right? So the function itself clearly says that boss, I receive only a number type variables. Okay, please don't send anything else. I returns only the number types. Please don't expect anything else. So that is clearly mentioned on the code itself. And in that case, if you try to send any string or anything else, no, that will tell in the compile time itself. It saves you a lot of time. Otherwise, in case of JavaScript, it will tell only in the runtime. So that's one of the greatest advantage in static typing. Okay. Yeah. Hope you guys are clear with the thing, I believe. So next, that's what I told you, inference. So what is the inference? You should just think, just come out of that techie, just think about what is an inference. So inference is like you just look at this figure, assume that you are actually listening your friend, and he is stating that you are actually listening your friend, okay? And he is stating that, hey, today I saw Raju with Puja in a mall. You're then you're recapping the moment. One recapping the older moment, you saw him with Puja in a food court, right? Then you're actually guessing like, okay, Raja got a girlfriend. Okay, okay, this is what. So the inference is something. What clues you notice, what you already know about it. Then coming to the conclusion, like, so as depicted in the picture, like you are actually listening something, you are actually getting some clues. What clues do you notice? Then your friend is saying that I saw him in a theater. Okay, then think about what you already know. You saw him in a food court as well. Then you are guessing like, okay, this Raja will be a Raja is got a new girlfriend or something, right? So that's how the same in technically if we think about, right. So whatever the value that you are assigning, say for example, I already this is a type instance is not is quite applicable to the any data type only. Okay, so something like if you simply probably the next slide will yeah. So the type inference, right? This is what the general think about inference. So here is type inference something like the process of determining the types of unannotated variables. P. So this is where any type. Okay, this it can accommodate any type of data. That is no harder than that. So this is a type inference of number. See, I haven't mentioned any data type. Did I mention anything in number or a string over here? No, right? I just simply mentioned where num colon equal to 3. I'm just assigning like 3 into the num. So that's what. So automatically the compiler, no? So the determining the types of unannotated variables. So there is no such annotations over here. There is no such type description over there, right? So by using the previous experience, the compiler come to know, okay, this is the number, right? So what will happen if you add 100 with that? You haven't said that this is a number, right? But you have to mention it. But you didn't mention it. This is a number. Yeah. So by the compiler itself concluded that okay, num is a number. Then you are adding 100 more. So what will be the result of here actually? Where is equal to. So of course then they will conclude that this is also a number, this is also a number, 100 plus 3, 103 will be the result. And anyways, I will show you the source code after this slide. Okay, that's what. Then what will happen if you do like this? So you are actually trying to assign a string data to the number, right? So here the compiler is already concluded that this guy is a number type 1, but if you are trying to assign add a string data over to that, then you will be getting a concatenated. The result will be like 103 string data. This will be the result. Anyways, I will show you the source code the time when you go to that. And this is something wrong. Okay, this is something wrong. You're actually declaring it res is a number, right? This guy will hold only the number type of only, right? So you should not place anything other than that, other than number, right? But we have mentioning like num plus string data. So in this case, actually, you're forcing this particular variable to hold the string data also. But sorry, sorry, sorry. Hold on. Yeah, you're forcing the res type to hold the string data as well. But you have declared it is the number, right? Then it will you will get an error in that in this case actually. Yeah, the type annotation. So types are annotated. Annotated means if you go and see the meaning of the annotation means it's a note. It's a kind of note for one particular thing. Here actually a note for one variable. Here actually I'm giving a note NEM. This is a type number. Okay, then only the number types will be accepted over to the NEM. This is the type annotation. Okay, so here you do not see that here everywhere I'm mentioning what is the type that I'm going to have it. See here also like I know what type of value I'm going to use it. So I just mentioning like I'm declaring it NUM is in the number, so it should hold only the integer. So I'm just using that. So this is a type annotation. So in this case as well. Again which I already shown, right? So we are already declared this as a number, but we are actually trying to assign the string data. This should be a error, right? So this should not be the case. Okay, let's have a look at the those things in our source code. I hope you guys are following. I'm sorry I couldn't able to address any of the questions. If you have anything, is there any option that yeah, let me answer CB's question. Is that option can be disabled? I mean, anyway, we can achieve as in Java. Yeah, there is no way to disable it, CB. In case if you want to write a JavaScript code, of course you can write your JavaScript code as well in TypeScript. There is no harm in that. Okay. I want where x equal to 1, x is equal to s, as we are using where here. Isn't it? Yeah, that. I want var x equal to 1, x equal to yes. Okay, as we are using var here. No, yeah, this is possible. This is quite possible. This is dynamic data type. That it is we can possible. This is possible. You will get a clear idea once I show the source code over here. Okay, and I'm okay. Let me probably. So this was the first example that we saw, right? The typical JS code. So it actually we have to do your type checking. So this will be this checking will happen only at the runtime in the JavaScript. But in case of TypeScript, right, this get reduced. You can simply mention it like receive it with that number type and the number type and return it also in number type. So this I would recommend you guys to go with this play. Unless otherwise, if you know what type what type of data that you are going to receive it, then please do it actually. Otherwise, if you don't have any idea the value that is coming from a third party or API, then you can go for any type. Okay. Yeah. Then here you can see that no. This is other class. Okay. Where you can find on function add numbers any. So here you can see that I haven't mentioned any type. So the param, if you go and place your cursor over there, you can find the note called any. So you can any. So the param 1 and param 2 or param 3 are these variables can accept any set of data. So you can pass number or a string, so or even boolean you want, you can send anything you want. If you send this particular function a number kind of thing, it will give you a numerically sum this particular thing and give you the result. If you pass a string, that will the entire string will get concatenated and will show you the output. Yeah, that's what. Again, if you know the type, you can easily go for you can mention your type or mention parameter with number. You know the number, right? So again, you please don't forget that you have to use colon over here. So colon is much needed everywhere. You mention your identifier and type. So just remember IT. Okay, this is how I used to remember. I means identifier and T means type. In between that, you have to place your colon because this is completely different phenomenon in TypeScript for the guys who come from C# or Java background. Then one more feature like right. So this is what the feature. This is what the variable is VO. Something if you forget it, if you by mistake, if you use IS, BS, something like that. No, if you by that's a spelling mistake you do in the code. Like in that case, in JavaScript, it won't notify you. It will notify only on the runtime. But in the case of TypeScript, if you do any mistake over here, it will notify you in the compile time itself. That is one more advantage over here. Yeah, I will show you that other set of codes. Yeah. See if here the type annotations and type number. Again, I'm going to show you the same example. Like if you know the number, if you know the type, then you please go get var age colon number equal to 10. So identifier and the type. So in between that colon, we are actually trying to assign it. Okay. So in case if you don't want to, if you do not know what type is there, you just simply var return age equal to 65. So with the help of type inference feature in TypeScript, as I already mentioned, the compiler will conclude that okay, return age based on the value that is assigning, it will conclude okay, this is a number. Well, internally that will treat it as an return age. So one more thing I forgot to mention, like whatever the code that you write in the TypeScript. So yeah, I think I forgot to mention one thing. I'm sorry. So when you go in the Visual Studio, if you want to use the TypeScript, you have to open your project like add TypeScript file, add new item, something like that. Yeah, this one. So this is how you need to add your TypeScript file into your project. Okay. So then, as soon as you write something into the TypeScript, if you go and save it, right, you can notice something into that below the item saved, right. So as soon as, say for example, just copy it again. You see that outputs generated successfully. I already mentioned like this, TypeScript is a supercoding language. Whatever the code that you write and you save that, it's automatically converted this particular TypeScript into JavaScript code. End of the day, it's going to be a JavaScript code. See if you show and go and show all files, our file is a student.ts, student.typescript. So student.js. So the typical equivalent JavaScript code will be keep creating. Okay, this is a JavaScript code. Okay, if you want to any clarification, you can go on that. And I would recommend not to include this particular thing into your project. Since you are actually using TypeScript, right? You just simply go with it and take your own. So this is one more thing. Then yeah, I don't want to take much time. This is already in time. So many things are there. Then one more thing, like if you want to use annotations for the string, as usual you can go for identifier, then string, and that's like the same what you did in number. In annotations, you can also annotate it as a boolean. How you need to do, so if you do not know the type, you can simply make it as a where the type equal to true. So the type inference again will do their job. While concluding it, this is the boolean. Yeah, see here. See here also I haven't mentioned any type, right? So where data is equal to 3. Using the type inference, that the compiler will come to know this is a number. Okay, take this 3 and add 7, and the new data will be 10. Okay. As usual. So here also I haven't mentioned this a string. The data is I just simply assigned Ramesh, right? So based on the content, the compiler will come to know this is a string, and for the next call, it will concatenate this particular string and assign it. So you can find that these are all the type, wherever the types influence, like I mentioned, it's any type. Okay, same set of examples. Yeah, finally, as for that, no. So dynamic. So here, no, I'm just mentioning it's a any type. Okay, dynamic yes. So initially, I'm just trying to assign something in string. After that, I'm just trying to assign something in boolean. So we can. This is quite same as we have in a dynamic keyword in C#. So dynamically, you can change your types accordingly. Okay. Then I already mentioned no, the unpaired and null. So that's what you can find out here. Yeah, this is all about the type inference. Then other one more important project that you have to see out here is like yeah. Yeah, one thing I forgot to mention, how you need to create a class. This is quite the same as how you do in C# or Java. You just simply need to create class and product. I mean the class name. There is no such difference over here. Uh, class class name. Then you have to use braces over here, open braces and close braces. This is a declaration that you have to follow for declaring a class. Say I just give you a detail example. 1 second. Here it is. Yeah. See, in this class I'm just actually creating a class. This is how you have to create a class. So in which I'm actually creating a custom private variable. Okay, then you have to use private. As usual, I mentioned like no, this is a custom code, or you have to use colon identifier then type equal to something. I'm not assigning anything. That's what. So and again the getter and setter property is also here. It's also available here. Only thing the way its interprets is bit different over here. Then you have to use set and get the keyword for the appropriate functions. In case of set property, you have to use the either the public right, then set the name of the property. In our case, our property name is a customer code. Okay, then what is the value that you are supplying? Okay, string is the value that you are supplying. Okay, fine. Values colon string, then again identifier, then type. Okay, then receiving the value and assigning it to this particular private variable. The same as like you do in the C#. Okay, there's no such difference. Then again, in case if you want to return something, then you can please note that in case if you want to return right, you have to use get the customer code colon string. This is something different. This is something interesting. You have to use that particular property name, then what it actually returns. Then again, whatever where the value is actually stored, this cust code, right? Then again, you have to return this particular thing. The same. Then again, this is quite the same function over here. I do not go. Yeah, no, this is how you need to create a class. So this is how you need to create a class. This is how you need to create a properties, get properties, and set properties. Then one more point I forgot to mention. How do you need to create an inheritance? Like, so yeah, let me complete how to create interface first. So this is how you need to create interface. This is also actually the same. So as I mentioned, no, there is no such difference for the C# or Java guys to understand how do you need to create interface. So simply you need to create an interface keyword and the name of the interface name. Then you can mention as whatever the function name that you place it over here. As like in C#, in case if you haven't implement this but any of this particular function in this particular class, you will get an error message and the compile time itself. Okay, this will save a lot of time, development time for the developer. Okay, yeah, the way how you need to inherit, no. So this is how you need to inherit. So the name of the class implements that interface name. What is an implement? So even the I do not know why Microsoft guys chosen implement keyword. Implement keyword is the one which is used in Java for inheriting the classes, right? So, but in this TypeScript as well, TypeScript is also one developed by Microsoft guy. That guy is much interested in implement keyword, so that's why he used the implement keyword over here to inherit something from the other interface or classes. So here in this case, it implements this particular interface to use it out. Yeah, this is how you need to create your class and interface. So this is one set example. Another example is like one which is already a yeah. Sorry. Here it is. Yeah, earlier we saw that how we have to inherit from a class, right? From a interface, right? Here we are actually seeing like how we have to inherit from a class. Same only thing. Uh, sorry. In case if you want to inherit something from a class, right? You have to use your extends keyword. Okay. So in this case, where you can so when you want to implement your any interface, that you have to use implements. Okay. So in case if you want to inherit from your class, then of course you have to use extends keyword. So this is the only thing which is taken from which is inherited from Java. Mm, yeah. So it's what the company is already been here, already created. This is the way how you need to create is almost the same as like in Java. The company name, this is how you need to create a function. This is a validate function. It receives a parameter, number parameter, and returns a boolean return type. So this is how you need to create a function. This is a function which receives an input type number function, and it returns the boolean. Okay. So that's how you need to create. So wherever you want to mention your type, you have to remember that your colon. So inside the parameter, you have to again repeating is it's bit hard to adapt this particular scenario. That's it. Okay. So when you want to return, you have to use again the colon. So also that when you don't want to return anything, that time also you have to mention colon void. Okay. This is how. Then the same as like you, right? You know very well that already mentioned this how you need to create a getter and setter property. So this is what you are actually receiving the value in the here. Then you actually trying to assign this particular value over here in this company code. The company code is actually a private end of the day. It's a private variable. Then finally you are actually returning this particular private variable. This is how you have to use as like C#. The only difference is like in C# you have to pack everything into the single function, but here this is getter and setter property is completely different. Other than that, there are no such comment that. Yeah. One more thing. Sorry for running, so it's taking good time. One more project is also there. Yeah, so you can find a lot of beauty over here, right? So we use it to declare only the functions, right, inside the interface. In C# or Java, in other example as well, we remember that we declare only the function that has to be implemented only in the client class. But what if you want to implement the variables as well, you have to use so you have a situation like whoever is actually implementing this particular interface, they have to declare all the three. They don't want to miss anything, any single. They don't want to leave product name as empty. They don't want to you don't want to fill only product name and product serial code. You have to fill the product type as well, right? In that case, you have to pack everything, whatever the thing that you need, and declare it in the interface and use it over here. See, the product details, I'm just creating another variable, product details, toy, and colon, then type, right? So in this case, the product details, if you see here, right, equal to that brace is where you have to mention all the three: product name, product serial code, and product type. All three content has to be filled. If you forget to miss anything, the compiler will not allow you to compile. Okay, that's the video here, right? So in case if you as a pack you want all the data to be built for one particular thing. In this case, it's a product details. You want the product name, product serial code, and product type has to be filled. Then put it into a interface. Okay. Then who is actually implementing that particular interface has to be filled all the three. So in our case, like the product details type has to get filled on product name, product serial code, and product type. This go. Other than that, the compiler will not allow you to compile. Okay. So this is one thing, and one more feature over here is like so see you are not sure that one variable can have a string or a number. That depends upon the condition. Like if the condition A matches the string types with will be accepted. If the condition A is not matched, the number will be campaign. In that case, we have to simply declare like type str or num equal to string or number. So the string or num is actually capable to hold either string or number. Other than that, if you pass a boolean value, it won't accept. Okay, that benefit is over here. Okay, you can use one particular variable for both the types. Then also that one more facility is tuples. The TUPL is tuples over here in TypeScript, where you can mix your types. If you want to mix your string and numbers, you can declare it as like this is how you need some data. This is a manufacturer details. Then you can declare your manufacturer detail like ITC remitter and the number. This is a string and this is a number. Then again you can take this value like 0 or 1 according to that. So that's how there are a lot of features is there in TypeScript. Yeah, one more feature is here, like generic support is there. So in JavaScript, you do not have any such facility. There are lots of codes, rewritten codes is being avoided here. See, I just mentioned a simple example here, right? Reverse. So this is a generic function. Okay, this function is actually applicable for any types. Okay, but in case of JavaScript, you have to write this particular code for a string for once and number for one more time. So that reusability comes here. Okay, I'm just creating a function called reverse, in which can accept any type. Okay, this can type any type. Even the parameters also, you can receive any type of parameter. What parameter that you're actually supplying, then also it receives. It returns. It returns the same type. Here I haven't mentioned any type, but it is applicable. It's a generic type for it's a generic type. You can use it for number or a string, whichever the way you want. So in this case, I'm just reversing this particular function, returning it. Okay. So see, I'm using actually for 1, 2, 3 new number I have reserved. I said that I just call this particular function. It shows that reversed. So reversing the integer. Then in this case, reversing the string. So forget about the reverse logic or anything. You just simply think about that. You can have your function. You can apply generics in your TypeScript. You can reduce a lot of code. Your maintainability is there. You do not have to run here and there to debug your functions and all. So one such function will take care of multiple roles on that. Okay. So again, it's quite yeah. There one more thing. You do not know what type of parameters will be coming. Either it is if you are sure that either the parameters will be string or string array, then you can go simply mention like this. So command. So the input parameter for this particular function, either it is a string array or it's a string. So I'm pretty much ready to receive values in this manner. If I get a string type, then I will go with this particular logic. If I get an array, then I will go with this particular logic. So that's how you can use it. This thing actually in this manner as well. Yeah, I hope I have covered everything. Then one more thing. Sorry. So I'm not going to run all these projects. Okay, you can simply download your projects and run it out. Otherwise, it will take more time to show you the output and everything and all. Okay, I'm just trying to explain each and every line. That's it. I will show you. I will share you the GitHub ID, GitHub link. You can just download that. Yeah, the final one is the module loader. Okay, we'll go back to presentation. Few more things are there. Probably that time we already discussed. Yeah, the way this is how you have to create a class. As usual, you have to use class keyword and name of the class. Okay, sorry. So the class keyword is followed by the class name. This is quite same as like other. The interface, it is also the same. So interface are not going to be converted to JS. It's a TypeScript feature. As I already mentioned, right? TypeScript is superset. TypeScript has JavaScript features plus own features, right? Plus the own features is there. In that one features, the interface and class is also there. So this is how you need to create inheritance. If you want to create inheritance in TypeScript, this is how you need to use. You have to use the extends keyword. So the customer is a class. Then special customer is a child class. So you have to use extends keyword to bring back. So to inherit it. So this is all. But JS do not have any concept of inheritance everything. Then again, then creating properties. Okay, properties. Then we saw it, right. This is how we just you have to use the set keyword and the get keyword for the getter. So getter and setter. Okay, so the name of the function, then how you actually receiving. So what is the type? It's a string, then value colon string. Then you have to assign this particular value to your local variable. Here it is not there. Then you have to use for getter. You have to return that particular thing. Yeah. So this is the one more, the final topic. Okay, the loader. The loader is one is quite. I am very much interested in that. So what is the loader? Why we have to use a module loader? So if you think about this particular feature, like so large applications often require large number of JavaScript files. So they are loaded one by one, right, using script tags. I hope you guys remember, like, so whatever the files that you remember, you have to load, you have to use script tags. Additionally, each file can potentially be dependent on other files. I agree. So the most common example would be like you have a class called customer. So you just see this particular diagram. Most common example would be like you have a class called customer, and the customer class is potentially dependent on order class. So the order class has to get loaded before the customer class. Agree, right? So also I don't want the order class is loaded throughout the life of the application, right? So it should load only when particular operation is needed. For example, when customer orders the product, not when customer visiting or glancing the site or doing window shopping. So when customer is really ordering the product, that time only the order class is actually needed, right? That's where loader helps. Loader actually helps you to load the required modules. So that's what, again I repeat, like in your Flipkart or Amazon, in any website that you go, you can simply traverse all the products which are displayed over there, right? In that time, your order, you just assume it. Order JS or order object is not going to be used. It's quite waste to load order class in order object into your memory unnecessarily. It's actually needed when you go for a checkout, when you go actually buying that particular product. That time only that order object is going to be used. Okay, so that's where the loader helps. Loader helps you to load the required models only when you require. When the customer is actually ordering that product, that time only this particular object is actually needed. That time only it get loaded. After, as soon as you finish that, it's go for other one. Right. So the loader, so to load this particular thing, this particular dependency for this particular customer JS, right? So system JS, Webpack, and record JS. These are the available frameworks which is already available. So in our case, in my example, which are I shown here, I used system JS framework. System JS framework I have used to load the dependencies for this one particular class. So you can also go for Webpack and record JS. Both are almost same only, but there are minor differences. I don't want to go that in much detail. So for that, actually you have to install npm. You have to install system.js. So system.js is the one which helps you to load your required modules to your project. Okay, so to install that, you have to use npm install system.js as mentioned over here. Then we will take care of. Then I will show you the code actually. Okay, this will in source code I will tell you how you need to install it, how you need to do your code. Okay, then again it's actually increases reusability and maintenance and everything. So that's what. One more beauty over here is like the system.js. If you look at this particular page, system.js loads files in order from top to bottom. Okay, and then instantiate from bottom to top. For instance, consider the example of file 1. Okay, file 1 which has a dependency on file 2. Okay, which itself has a dependency on file 3. Okay, so when you ask system.js to load file 1, it will first load file 1, then check for dependencies. It will see that it has a dependency on file 2. Okay, so it will load that next, and then because of the dependency on file 3, it will pull down file 3 file as well. Once all of those files have been loaded, it will actually execute the contents of file 3 to get the instance of the module, then execute file 2, passing the instance of file 3 to file 2, then it will take the return instance of file 2, then pass it that to file 1 when instantiating it, then finally then pass the instance of file 1 to the consumer. That into the original import. Okay, so that's why the system.js also catches the loaded module. If any point in that process one of the modules have been loaded previously, then system.js will use the cached version instead of performing action loader on instance steps. So again I repeat, to load your dependencies, this is a way, this is the structure, this is how the system.js loads. First we'll look for the file 1, then any dependencies, then file 2, then file 2 has any dependencies, then file 3. Okay, this is how they are loading it. So in case of instantiating it, so completely quite reversible. First creating the instance of the file 3, which is one sits in the last, then passing the instance of file 3 to file 2, then creating the instance of file 2, then passing the file 2 instance to the file 1, then creating the instance of file 1. Okay, I'll show you, so probably you'll get a better idea on that actually. Okay. See, I have two TypeScript. Okay, two files. One is a customer, where I can have order where I'm referring order object. Okay, so the customer is the one class where I'm referring the order object, then customer code, then actually I'm adding this particular customer. So to use this particular customer class, I have to use orders as well, right? So for that actually I'm importing this particular component, that import orders from dot orders. So this is how the hierarchy, right? So I'm just importing it. So importing this particular orders and using over here. So without this particular line, this guy may not know how to load this, how to create an object. So this is how I need to mention here. Then orders, I don't have any much order thing. Only thing you have, I'm just creating a variable and then one particular function to order function. So the idea of this guy, the customer object will refer the order object to create any order. This is quite simple. Okay. So one thing you have to remember, right? Whenever you want to expose your class to the others, you have to use export keyword. Without using export keyword, okay, this guy would not be able to import it. Once you export it, then only this guy can able to import it. Without import, then this guy would not able to utilize the order functionality. Okay, you got that point, right? So this is how it works in TypeScript. Yeah, I'll show you the one more. Yeah, so that's what. So here, if you look at that, this is a basic HTML page. It's a basic HTML page. I'm just hard coding it. So user option is an order products. So only if the if the user option is order products, I am going to import the customer class, that is customer JS, then use the dependency components. Okay, then you just importing this particular customer.js component, that imports will get exported over here. Okay, then I am going to create a exports.customer. This is the syntax you have to follow it to import any module and load it out. Okay, so once you load that, you can assign customer code, then customer, add customer, anything. Then only you can assign order number or anything, whichever the objects that are there in the dependency object. See, this customer class has the dependency of order. Unless otherwise the order has been created, this customer cannot be able to create it. Okay. Also that I don't want this particular customer and order will get created throughout the life of the project. Only during the time when customer order products, that time only the system is actually importing customer objects, then with the order objects. Okay, so here I just show you only this particular thing. See, one second. So basic HTML page. Okay, so if you see that, so as soon as the customer object gets created, you can find that order JS also get created, right? Okay, because I have mentioned over here in my page, I mentioned like my user option is order products. So as soon as the user option order products is there, then it will import the customer JS, then creating the object for the order object as well. So the dependency also been created by the system JS. So what if my user option is other than that, like order cancel? If I go that and load this one, no. See. So those dependencies has not get loaded. So system.js will take care of. So see, you're not able to see because I just bypassing it, like only if the user option is order products, the rest of the modules has to be get loaded. Other than that, I don't want any other modules to get loaded unnecessarily. So in that case, I'm not seeing any such case over here. Any other order or customer modules will get loaded. Okay, this actually increase the responsive. This will increase the performance of the website. See, again, I'm just reverting like this one. So again, it's loaded. So this one, so loader is actually helps you to load the required models when you actually needed it. Yeah. So I'm done actually. So if you have, I think, hope you guys had a useful session, I believe. So if you have any questions, please. Yeah, definitely, Shibish. I will upload it and let you know. Yeah, yeah, definitely. You can think about. You can please note it the GitHub link as well. So I recommend you guys to please note it down my Twitter ID and email, Gmail ID, and also GitHub as well to download the required source code and everything. So please don't forget there is a underscore sits between the TypeScript and basics. So you may not know the screen. So this is what my GitHub ID. So you please download your required content and use it. In case if I'm not able to tell anything, sorry, solve any of your questions, please write to me. Uh, I will try to help you as quick as possible. Okay. Okay. Thank you everyone for attending it, even though it is in a weekend.